Hello. All right, so if you guys can turn to page 4 of your packet, we're going to talk a little bit more about exponential functions. And today we're going to talk about something called logs, which is the inverse of an exponential function. All right, so yesterday we talked about how to graph, right, y equals 2 to the x power. And I'm going to graph it. I mean, if you flip back to page 1 of the packet, I'm going to use the same exact x and y values here as we did on page 1 of the packet. So if you go to y equals in your calculator, right, and plug in y equals 2 to the x power, and go to your table of values, I'm going to use these same x values that we used on page 1 of the packet. So if you look at your table in the calculator, you'll see that the y value that corresponds with the x value of -3 would be 1/8. Okay, the one that corresponds with the next value of -2 is 1/4. And then I'm just copying right down 1/2, 1, 2, 4, and 8. All right, so what we're going to do is we're going to plot these coordinates on our graph. And I usually, I'm going to work my way up the chart. I'm going to start with the whole number of points. So I'm going to first plot the point 3, 8. So over 3 and up 8 would be right here. Then I'm going to plot the point 2, 4. So I'm going to go over 2 and up 4. I mean, you could plot these right in order, but I usually like to do the whole number of points and then work my way up to these fractional points. All right, and then we're going to graph the coordinate 1, 2. So over 1, up 2. And then we have 0, 1. All right, so now -1 and 1/2, I'm just going to go back 1 and up 1/2 and put a point. All right, and then, it's going to be harder to plot these, but if I go back 2 and up 1/4, I mean, up 1/4 is like, just a little way up. I'm just going to do my best to show that it's lower than this one, but, not touching the x-axis. So put that right there. Oop, that's probably a little too low because the next one has to go even lower. All right, there we go. So I'm going to connect these. And my graph is going to look like this. Now, what I want you to notice, and remember this from yesterday, that this right here doesn't actually touch the x-axis, okay? As I work my way to the left on the graph, right, this is going to get closer and closer to the x-axis, but it's never going to actually reach it. Okay, these fractions, as you work your way up the table, if you scroll up in your calculator, you'll notice the fractions, they're becoming smaller and smaller and smaller, right? But they're never going to hit, y is never going to hit 0. So remember, we have an asymptote right here at the x-axis, right, which has the equation y equals 0. Okay, so let me label that y equals 2 to the x. So that was a little bit of a review. Now what we're going to do today is we are going to graph, let me actually move this over a little. We're going to graph the inverse. Now if you recall from the last unit, when you want to find the inverse of something, what we do is we switch the x and the y. Okay, so if you notice here in this equation, it used to say y equals 2 to the x. This one, if I switch the x and y, says x equals 2 to the y power. Now, I'm not going to go over this with you today. We're going to learn this later on in the week. But, whenever you find an inverse, you're supposed to solve for y in that equation. That way, if you wanted to plug it in your calculator or whatever, you could. I'm not going to go over with you today how to solve this for y because that's a total lesson in itself. But when you actually do solve this equation for y, this is what it looks like. Y equals log 2. And this is a base, right? This is like a little subscript. It's lower and smaller. Base 2 x. So y equals log base 2 of x. All right, but anyway, if I want to graph this, since I switched the x and y in the equation, right, what I'm going to do is I'm going to switch the x and y coordinates. So all of these x values right here are now going to become my y values. And all of these y values are now going to become my x values. Sorry, this is kind of messy. I always find it hard to write on this thing. All right, so there we go. So now I'm going to plot these. I don't know why, but I always like to plot, like I said, the whole number of points first. So I'm going to work my way up this table. So I'm going to first plot 8, 3. I feel like it just helps me show the trend of what's happening in the graph better. So I'm going to go over 8, up 3, and put a point. Okay, then I'm going to plot the point 4, 2. So I'm going to go over 4 and up 2 and put a point. All right, now I'm on the 0.21. So let's go over 2 and up 1. The next one is 1, 0. So over 1 and up 0. Now, these are the ones that you're just going to do your best, to fit on them. They're not going to be exactly, but I'm going to go over 1/2 and down 1. So I'm going to go over 1/2 and down 1. So that's like right about there. Okay, let me make this bigger. That might make it easier for me to plot points. All right, there we go. So the next one says 1/4, -2. So I'm going to go over 1/4 and down to -2 and put a point. All right, so that's going to be right about here. Okay, and then finally I'm going to plot this point 1/8, -3. So I'm going over 1/8, which is very slightly, and down to -3, and I'm putting a point there. Okay, so there we go. So if I were to connect these, we can see that my graph looks like this. Okay, and I'm going to zoom back out a little bit now. Let me put the arrow over here. Okay, now I'm going to label this graph, even though we don't know how to make this equation yet. I'm still going to put it in the form y equals. So I'm going to label this graph y equals log, and that little 2 is a base, so it's small and lower. Right? It's a subscript of x. Like that. Okay, now what you notice is just like my exponential, right? This, if you recall from yesterday's exponential growth, as you go from left to right, it's growing over time by a rate. Just like my exponential function never touches the x-axis, my log function is gonna, as you go this way, is gonna come closer and closer and closer to the y-axis, but it's never gonna touch it, okay? So it has an asymptote right here. The y-axis is the asymptote, okay? So it's gonna come closer and closer and closer, but it's never actually going to reach it. Okay, so number 12 and number 13. Okay, so number 12, it says, what is the equation of the asymptote to the graph y equals 2 to the x power? All right, well, this is the graph y equals 2 to the x power, and we said the asymptote is the x-axis, right? The x-axis is the line that the graph is approaching, but it's never going to reach. So the equation of the x-axis is y equals 0. Okay, remember, any horizontal line is y equals, it goes through the y-axis. All right, now, number 13, what is the equation of the asymptote to the graph y equals log base 2x? Well, the asymptote to this, as we said, is the y-axis, right? It's coming closer and closer to the y-axis, but it never reaches it. So the equation of the y-axis, right, any vertical line has the equation x equals, and in this case, it's going to be x equals 0, crosses through the x-axis at 0. All right, number 14, describe the end behavior of the graph of this function right here. Okay, so as far as end behavior goes, what we want to do is we want to talk about what the function does as we go to the left and what the function does as we go to the right. So I'm going to say as x approaches, I'm going to fill that in something in a minute. Now don't say f of x, because if you look here, they're using y. We're going to say y approaches something, and we'll fill that in a minute. Then we want to talk about what happens as we go to the right. So we're going to say as x approaches something, y approaches something. All right, now let's think about this. So we said the first one, as we go to the left on the graph. So as we go to the left on the graph, aren't these x values, think about this is the x-axis, aren't the x values just going further and further and further in the negative direction, right? So we could say as x approaches -infinity, the y values, well, what's happening to the y values is even though they're getting lower and lower and lower, they're never going to come down here in the negatives. They're actually never even going to reach 0. What's happening is they're approaching a height of 0, but they're not actually reaching it. So as we go to the left on the graph, as x approaches -infinity, y is approaching a height of 0. So this, we're going to put a 0. And then over here, as we go to the right on the graph, aren't these x values, right? See the x-axis? Aren't the x values getting bigger? And at the same time, the x values are getting bigger. Isn't this graph going up and up and up and up, so the y values are getting bigger? So they're both approaching infinity. The x values are getting bigger, and so are the y values. Okay, so now let's talk about, in number 15, describe the end behavior of our log curve right here. All right, so we're going to start it off the same exact way as we did the other one. As x approaches something, we'll fill that in a minute, y is going to approach something. And as we go to the right, so as x approaches something, y is going to also approach something, right? All right, so let's figure out what these somethings are. We're going to fill in the blank. So as we go to the left on the graph, so we're going to the left, so we could say as x approaches. Now, I know over here we said negative infinity, but we're not ever using any of these negative x values, right? Because didn't we say this graph right here is going to come closer and closer and closer to the y-axis? Isn't the y-axis where x equals 0? So this graph is, as we go to the left, it's going to come closer and closer and closer. It's going to approach x, an x value of 0. So we could say as x approaches 0. Well, as the x values are getting closer and closer to 0, aren't the y values just shooting down and down and down? So y is approaching negative infinity. And over here, as we go to the right, so as you work your way to the right on the graph, right, as it's getting bigger and bigger and bigger, aren't these x values getting bigger, right? But also, doesn't this arrow, it's going to keep going up. As you go to the right, it's going to keep going up and up and up. So the y values, even though they're not growing as fast as the x values, they're getting bigger too. So these are both positive infinity. Okay? And one thing I just want to point out is because an exponential function, this red curve, is an inverse of this log function, the blue curve, if you notice, look, the x's and the y's, see, these are switched. Here, x approaches negative infinity, y approaches 0. Here, x approaches 0 and y approaches negative infinity. See, they're flip-flopped, the x's and the y's, even up here. Okay, and that's what happens with inverses. All right, and then it looks like there's a question on the bottom of the page. Let's see what this says. Which statement about the graph c of x equals log base 6 of x is true? All right, now here's the thing. Let me quickly show you how to graph these in your calculator. Okay, so this is what you're going to do. You're going to hit y equals, and here's the deal. Even though I'm kind of trying to look, even though there's a log button, we don't want to graph y equals log of x. Do you see how in the question, can I move this down? Let me see something. Oh, no, I can't. But anyway, see on the question number 15, there's a log. It says y equals log base 6. If you want to use a log base, this is what we do. We hit the math button, and you could either scroll up or down. I actually find it's faster to scroll up because it's all the way at the bottom. And see, what is that, letter A says log base. Hit enter on that. If you have one of the older calculators, it actually doesn't have the ability to do this. So I could show you how in your calculator when I'm back tomorrow how to do this. But if not, just borrow one of my calculators or look on with the person next to you, and we're going to hit log base. And then it allows you to plug a base in. So I'm going to make that a 6. And then I'm going to scroll over here and make that x. And you could hit graph. I'm going to hit zoom 6 because I don't know what sort of window my graph is on. So zoom 6. And what you'll see is this graph looks really similar to the graph that we had at the top of the page. Okay. The only thing I want to point out is if you notice here, right, it almost looks like the graph comes to a stop. It doesn't. It's going to continue to go down and down. The thing is like, look how small this screen is. Okay, your graphing calculator only has so many pixels, so it's not able to show you what's actually happening. But if you were to continue with this graph, this would come like, it would continue to go down and just get closer and closer and closer to the x-axis. Okay, so what I'm going to do is I'm just going to sketch this because I can't really have the calculator at the same time. This right here, I just want to point out, it does go through the point 1, 0, but the graph looks something like this. It actually looks very, very similar to the one we had at the top of the page, y equals log base 2 of x. Okay, but this is y equals, with the base 6, it's just going to grow at a different rate than the log base 2 would. Okay, so this is what this is what the graph looks like. So we want to know which statement is true. Okay, so the asymptote has the equation x equals 0. Well, x equals 0 is the y-axis. That's true right there. The first one's true. Okay, this graph is going to come closer and closer and closer to the y-axis, but never reach it. So the asymptote is the y-axis, which has the equation x equals 0. So that right there is your true statement. Okay, just to quickly go through the others, the graph has no x-intercept. That's false, because here's the x-intercept at 1, 0. Right, the domain is a set of all reals. Domain is the x values you're allowed to use. You're not allowed to use all real numbers, because remember, we're never going to use the negative x values. And then here, the range is the y values, is the set of all positive reals. Well, the range, the y values, does go into the positives, but doesn't it also drop down into the negatives? So this is a false statement as well. Okay, number 16. If f of x equals x to the a power, where a is greater than 1, then the inverse of the function is what? Okay, if you guys look back on page 4, if you remember, the first thing we graphed was y equals 2 to the x power, right? And we said if we want to graph the inverse, right, on the top right-hand side of the previous page, what we did was we switched the x and the y in that equation. And although I said I'm not going to today show you how to solve for y in this equation, didn't it say in parentheses underneath it? Okay, I'm looking right at the top of the previous page. Y equals log base 2 of x, like that, right? So y equals 2 to the x and y equals log base 2 of x are inverses of each other. Okay, so that being said, here, a is just a number greater than 1. So isn't 2 a number greater than 1? So can't we use f of x equals 2 to the x? Same thing we have here. So if we wanted to find the inverse, wouldn't it just say f inverse of x equals log base 2 of x? Okay, so let's look at which one says log base. Now instead of a 2, remember this says a, log base a of x. Well, here it is right here, choice 3. So choice 3 is our answer. Okay, number 17. Which sketch best represents the graph of x equals 3 to the y? All right, well, let's look over here. If x equals 2 to the y equals this equation, wouldn't x equals 3 to the y be the same exact thing, but in place of instead of a 2 being in the base, a 3 would be in the base? Okay, so we're looking for y equals log base 3 of x. So what I'd like you to do is in your calculator, let's graph this and see which one of these graphs looks like it. I mean, you could probably tell just by looking which one of those graphs looks like what we have as a log curve on the previous page. But if you want to do it in your calculator, okay, we're again going to go to y equals. And remember, to get log base, we hit math, and we go, it's faster to go up than down. We go up to choice A where we see log base and hit enter. And let's just make that base of 3. And then let's scroll over and make that an x, and you can hit graph. And that is what our graph looks like. So if we look at the answer choices, it's got to be choice 3. Okay, that looks the closest. If the graph were to continue on and it looks like it's zoomed in a little bit, that would look like choice 3. Okay, so number 18. They want us to graph this on the set of axes below. All right, so let's first, if you think about it, we already know what log base 2 of x looks like. Now remember, I just want to point this out. If you add or subtract a number within the function, doesn't that shift it to the left or to the right, right? And remember, if it's a plus sign, it actually shifts it to the left. And then remember, if you add or subtract the number to the end of a function, doesn't that move it down, right? And if it's a minus sign, it shifts it down. So this just says that it's shifted 5 units down. Okay, but either way, I'm going to use my calculator to graph this. So I'm going to go to y equals in my calculator, and I'm going to plug in log base 2 of x plus 3 minus 5. Okay, so I use log base again, and I just plugged in a base 2, and then x plus 3 in parentheses minus 5. All right, so you could hit graph if you want. You could see what the graph looks like, but the only thing is that I have my window set up from -10 to +10, and you could see that x-axis goes a little bit further than that. But either way, we usually go to our table of values to figure out what points to graph. So let's hit second graph, and you're basically going to include any points that not only fit on that graph, but that are like, I would say, whole number, right? Integer points. Like you're not going to try to graph, this one right here, the y value of -2.678, because that's not going to be super accurate. But let me just scroll up for a minute. Okay. Oh, if you notice, see right here where it says error? The reason it says error is because we have an asymptote. Let me go back to the graph for a minute. Let me graph. If you notice, you know how if the graph wasn't shifted, the y-axis was our asymptote, right? The graph came closer and closer and closer to the y-axis. So that was our asymptote. Here, didn't we say that it was shifted 3 units to the left? So really, instead of the y-axis being our asymptote, we're going to have an asymptote at x equals -3 because we're shifting it 3 units to the left. So let me go back to my table of values. So second graph. So basically, if you see here, at -3, it's never going to reach -3. That's why it says there's an error. And when x equals -3, -4, -5, and so on, you're going to see an error because it never reaches those points. Okay, so that means our asymptote is at x equals -3. That's where we start. You know, that's basically the x value it's going to approach but never reach. All right, so you guys are going to plot whatever points you could see. So -2, -5, -1, -4, 1, 3. I'm sorry, 1, -3. And then if you scroll down, whatever whole number of points you see, like there's another one, right? 5, -2. Whatever points you could see that fit on there, you're going to plot. And is there any more? Yep, right here, 13, -1. Those are the only points you're going to plot. So take a minute and plot those. Okay, I'm going to make this a little bigger for me to plot it so it's easier, but I think the first point we said was -2, -5. So I'm going to go back 2 and down 5, 1, 2, 3, 4, 5, and put a point. Okay. The next one was -1, -4. And then we had 0 was not a nice clean y value. At 1, +1, we're at -3. And then if you keep scrolling down your table, at +5, we were at -2. And then at 13, I'm going to have to count this out. So 5, 6, 7, 8, 9, 10, 11, 12, 13, we're down here at -1. So at 13, I hope I counted that right. Let me just count that again. I think I'm off by 1. 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that has to shift over 1. So let me do that. That should have been here. Get rid of this. Oop, I guess that was not the eraser. There we go. Okay, so this, I'm going to kind of zoom back out. These are the points that we are able to plot. Okay, so my graph is going to look something like that. Okay, and make sure that you don't cross over x equals -3. It's going to get closer to it, but never actually reach it. Okay, so this is the graph of y equals log base 2 of x plus 3 minus 5. Okay, so they asked us to describe the end behavior. So as far as the end behavior goes, we always know we start off as x approaches. We'll figure that out in a minute. This time it's y, right? Not f of x. Y is going to approach something. And then we're going to say the same thing, and we're going to discuss what happens as we go to the right. Okay, so for this first one, we usually talk about what happens as we go to the left. So as we're going to the left, the x values are going to get closer and closer to -3, right? They're never going to reach -3, and they're never going to cross it. So as x approaches -3, we can see our y values are going to go lower and lower and lower. So y is going to approach -infinity. Okay, and then as x approaches, well, as you go to the right, the x values are just going to keep getting bigger and bigger and bigger. And as they do, the y values are going to continue to get bigger and bigger and bigger too. So these are both going to be positive infinity. Okay, so number 19, I'd like you to, I'm actually doing this in the calculator as we talk. I'd like you to, oh, look at this. It's actually the same exact graph as the last one. Okay, so we don't have much work to do. It's already in the calculator. But the only difference with the instructions is it says, use an appropriate scale to include both intercepts. So this is our graph from the previous page. Although it was intersecting the y-axis, it never intersected the x-axis. We're going to have to keep going and going and going in order for it to intersect that. But the only problem is if you notice, right, this, what was this at, 13,1? That means the X-intercept is going to be a much bigger number than 13. So the reason they say to use an appropriate scale is because this right here, only goes to 10. So we're not going to fit. So we're going to have to just figure out what to number by. All right, so just look in your calculator and let's scroll down until we see what the x-intercept is, right? Remember, the x-intercept is where y is equal to 0. Okay, so what I did was I scrolled down the table and it took me to an x value of 29 until y was equal to 0. This is our x-intercept, 29, 0. So, I mean, you could number this however you want, but if this is 10 boxes, I mean, I would jump by 3s, right? Because then that would bring you to 30 and you would be able to fit this. All right, you don't have to number all the numbers, but, okay, so I numbered by 3s, but I put every other number just so it wasn't like such a mess on there. So I skipped a box and put 6, skipped another box, put 12, and so on. And as far as the y-axis goes, I mean, I want to number the y-axis by 1s. So this is going to be -1, -2, -3, -4, -5. You don't have to number them all. As long as you put one number on there, you'll be able to tell what's what. So let me make this bigger. Okay, I don't know what just happened to that. Let's erase that and do that one again. But the -6 is going to go here, right? And then as far as the y-axis goes, I mean, I would just go down to -5 and just put the thing. I mean, if you want to number them all, go for it. You can do that. I mean, I guess because I'm zoomed in, it's like easier for me to make it fit. If I wasn't zoomed in, that would be really hard to fit. All right, so let me just zoom back out, and there's my graph. All right, so now you can plot the points. Okay, so I plotted them. And, I mean, keep in mind, like, when you graph this first one, -2, -5, this first box back is -3. So you're only going 2/3 of the way down there and then down to -5 and putting a point. Okay, -1, you're just going 1/3 of the way over and then down to -4 and putting a point. So this is what our graph looks like. Okay, and when we describe the end behavior, this is the same exact thing as we did on the previous page. So describe the end behavior as x approaches -3. Okay, so as x approaches -3, didn't we say, I think they called it, no, so y approaches, well, as the x values, right, are getting closer and closer to -3 right here. So as we're going this way on the graph to the left, aren't the y values dropping really, really low, right? They're going to continue down to -infinity. So there we go. And then as x approaches +infinity, so as we go towards +infinity, right, as the x values are getting bigger, aren't those y values also getting bigger? So as x approaches +infinity, y approaches +infinity as well.